And together with our SSD expert Steve, today we are going to talk about how do you actually go about achieving efficiencies that are typically available at the hyperscale level, and how do you actually go about choosing the right components to do that. So we saw some of this early on in Raj's keynote presentation. I'm going to dive a bit deeper into some of the topics that he covered today morning. But basically, yes, everybody knows Seagate as a hard disk manufacturer. Having shipped a couple of billion drives and being one of the couple of standing vendors in this industry. We are obviously a leader in storage components. What many people don't know is that we do much more than hard disks. We have an extensive portfolio of SSDs that we are going to talk about today. And we also invest heavily in building software level intellectual property in order to provide complete storage solutions to our customers. And one interesting thing is, because pretty much 40% of the world's data resides on Seagate disks, if you have ever used a laptop, a desktop, if you have any kind of hard disk device ever in your machines, you are probably already a Seagate customer, right? And if you have been uploading your data onto cloud, if you're putting your stuff into social media sites or public, private, hybrid clouds, you are already using Seagate drives in one form factor or another. So thank you for that. Let's take a quick look at the market dynamic. We have essentially seen the data storage exploding, right? And like literally almost from nothing and an exponential growth going up. This is where we are today. And while this is not news to anybody, what's kind of really most surprising is this blue part here that's growing really, really fast. And can anyone guess what that is? That's cloud, right? So while some of the other portions are shrinking, relatively speaking, we have seen a tremendous amount of growth in the proportion of data that's going into cloud. And primarily that's for two reasons. One is you are actually seeing like an explosion of devices, like we heard from Diane and others today morning, right? We have billions of devices pushing data, but also where the data is actually going, right? The data is, people are like, are you seeing problems because laptops and desktops don't have hard disks? Not really, because in the data centers where you eventually push the data, you still need a bunch of hard disks, and we're going to talk about different kind of hard disks that do that job. So we expect that this portion will eventually be half or more. So more than half of the data, let's say in about 2022, will actually start pushing into cloud. That is the impact that we are seeing of the cloud. And what does that do to the infrastructure is it has fundamentally transformed the way people build their data centers and IT infrastructure, right? The traditional way is here. It's pretty straightforward. Life was simple. SAN and NAS boxes here, right? Compute connected to this, network, standard stuff. Worked great. And when you wanted more capacity, you would pull in a more powerful server. You would buy the next filer. You would improve your network bandwidth. It worked. The problem was it's not flexible. It took months or quarters often to roll out a new service. It's kind of really hard. And the costs were super high. We are talking about $500 plus per terabyte of cost here. So the world has kind of moved into hyper-converged and hyperscale. And the terms kind of sometimes get merged a little bit because of the word hyper, but they are two very different things. They have a lot of things in common, but they are two very different things. The hyper-converged infrastructure, today morning we saw some definitions, really good ones, but basically think of it as a pre-integrated network, compute, and storage, like kind of in a box, pre-packaged. We're dealing with typically one single vendor, right? A lot of it is in news with the Nutanix IPO last week, right? So a lot of mid-sized enterprises started as VDI, but a lot of mid-sized enterprises kind of really using this, and it's a huge space. So a lot of opportunity for growth for players like QCT here, right? So a rapid shift from this to this. And then what we have also seen at the other end is the hyperscale guys, right? The companies that are having literally megawatts and megawatts in their data centers. You're talking about hundreds or actually exabytes of data in their data centers every quarter, right? The likes of Microsoft and Google and Facebook, Apple, all those guys. And they did it in a very, very different way. They do not want the compute network storage prepackaged. In fact, they want it disintegrated. So this is now a disaggregated set of commodity compute and commodity storage connected over network, all managed by software. And this is the fun part. Why is this fun? Because now you see, although these things look very different, there are a lot of commonalities between the two, right? It's the core intelligence in both cases is not like, say, in this case, there was a storage controller sitting here, right? This got moved here. Now, you're also looking at that intelligence being in software. And all these components are becoming very, very standardized, kind of off-the-shelf components. So then we come to the world of SDDC, and it brings in multiple benefits. You have cost benefits, as I said, standardized hardware. You're not paying a huge premium for very, very custom hardware in most cases, right? There is ease of maintenance, and all this is awesome. But the primary reason why companies are adopting it is business agility. So if you as a company, as an enterprise, are not using hyperconverged or hyperscale, depending on how big you are, right? And your competitor is, in today's world, what it means is you are rolling out your services a quarter or a year later than your competition. What does that do to your business, right? It's a matter of literally seconds and minutes and hours, and the hyperconverged, hyperscale infrastructure gives you tremendous benefit in terms of rolling out the time to market, time to money. It doesn't stop there. The ability to change and adapt depending on your requirements to scale up and scale down, to change the performance requirements, the capacity requirements of your infrastructure make a huge difference. So it's kind of an imperative to use both. If you are a mid-size enterprise, typically I would go with a hyperconverged kind of infrastructure. Beyond a certain size, kind of really go with a hyperscale. So it's an imperative to use one of these in today's world. And when you come to that, the key thing becomes, of course, the software, which holds most of the intelligence in your system, but also choosing the right components. It's not like you go to your hardware shop, buy some hardware and put it together. That's not the way it works, because there is, as you see on this slide, really different flavors of components, and I'm going to focus on storage components here. There's different kinds of components, and you have to be very careful about your choice of components. This is the complete spectrum of Seagate components. On this side, you will see the SSDs, and we are going to have a deep dive into that. There are client devices that go into laptops, desktops. There are NAS filer components, and some things optimized for surveillance, video, media backup, and other things. But let's focus on this dark blue part. There are mission critical drives, as we call them, which are really higher performance. So these guys are optimized for typically giving you higher throughput, IOPS per terabyte, as we define in this industry, right? So you want a lot of I/O going out. And on this other end of the spectrum, the content archive drives, these are optimized for capacity. So you're talking about drives that are 4, 6, 8, 10 terabytes, one single device, right? And you are getting that every gig or every terabyte at a really, really low cost. And then in between, you are looking at workloads, which are like big data, which are actually not archived. You still access it pretty frequently, but it's not as high IOPS intensive as a typical OLTP workload. So it's not a database access where you're going multiple IOPS every second, but it's not as cold as you store it once and you read it once, if that, right? So you have a complete spectrum of application work requirements mapped to a complete spectrum of disks. And the key thing here is to choose the right device. You get the wrong kind of device, you don't have the right performance for your application, you can't change things as fast, it's going to sputter, it's not going to scale, or you're going to run out of capacity very frequently. So the key thing is to choose the right device and to work with the right partner like Quanta, like QCT, like if you are going down to optimization, work with us. So if you have a sizable installation, we are talking about 1,000 servers, 5,000 servers and above. If you are consuming petabytes of storage, you want to really work closely with your system vendor, HCI vendor, and also with your device vendor. So when you work with a company like Seagate, we will actually come in and talk to you about roadmaps. What's coming next? What should you plan for 12 months in advance, for 24 months in advance? What should you do today in terms of optimization like queue depth so that your performance in 12 months is the right thing, right? So all those things, and that gives you unique business advantage. We are also talking about architecture. What kind of architecture makes sense? What happens if you have a problem with your infrastructure? Who do you contact? How do you get quick support, right? And finally, of course, supply planning. In an industry where we work in and ship to 170 countries, have one of the largest supply chain infrastructures on the planet. So working with a company like that ensures that you actually can get access to the storage devices you need when you actually need them. And it doesn't stop in terms of building components today and having them shipped on right time and supported, but does the company have a vision for storage, right? And you will find that Seagate has the most compelling vision for developing storage for the future. And we are talking about, when we say future, it's not 2 years. For a lot of our companies, right, in today's fast-moving world, roadmap is 12 months, 18 months. We have drives running in our labs which are already spinning for 3 years, right? So we are talking about roadmaps and planning that goes a decade or beyond. So technologies today, we already have launched what we call as SMR, shingled magnetic recording. You get denser drives. We launched our helium drive, 10 terabyte helium drive in February. It's a 10 terabyte, highest capacity, best power performance ratio for that category. Bet the competition there handily. So those two are already out. We continue to enhance. We'll launch a 12 and a 14 in the next few quarters. We are looking at newer technologies like TDMR. HAMR is the next big thing. So if you're looking at what's going to happen in storage, how do you push more data, what we call as areal density on a drive, right? That's HAMR. It's coming soon. We have some HAMR drives running in our labs already. And then it goes further into HDMR and others. So from today's 10 terabyte per drive, we are looking at a roadmap to 60 terabytes and above. And we are talking about price points that are kind of really, really ridiculous, right? I mean, you know where the price points have already come, but we are talking about a few tens of dollars per terabyte, right? So it's a really, really attractive price points. And all those pictures we take and the videos we take, they are going to be secure in clouds. And they are going to be available for all of us at really, really low cost, typically for free, because of all the innovation that's going into storage. So work with the innovation leader, partner like Seagate. And this is a slide that you want to read at leisure. I'm not going to go through it. But basically what we are saying is, as an organization, you care about business agility. You care about cost. Those are the two core pillars. And you can get them by applying the right kind of infrastructure, whether it's hyper-converged, depending on your scale, or hyperscale. And to do it right, you work with QCT, you work with Seagate, and through that, you get the best of our pricing, the best of business terms, support, supply, and a true partnership at the technology level. So with that, I will hand over to Steve, who is going to walk us through some of our innovation on SSD side.
I'm Steve Telgener. I'm a technologist within the Flash group at Seagate. My primary goal in life is demand generation for Flash products at Seagate. I have one of the greatest jobs there is. I get to go out to rich media, telco, and the financial industry and try to figure out what they're doing in their next generation, along with, the project that they're turning on today. And what I want to talk about today is what I'm seeing in the software-defined storage environment, especially around Flash. So, what we saw, I'll start with a roadmap first. or at least what our product offering looks like. So from a flash point of view at Seagate, we have a very diverse portfolio. We offer SAS, NVMe, and enterprise SATA drives. Everything is designed with PFAIL, so these are truly enterprise devices. In the SAS environment, 12 gigabit SAS, and then I'll talk in a minute about some of our newer offerings. In NVMe, we have both U.2, which is the 2.5-inch device, and then the gum stick, M.2, these here, and then also add-in cards. So really every aspect of that type of a device. And then in the enterprise SATA, same thing. We have M.2 and 2.5-inch devices. Just recently at the Flash Memory Summit, we made some first announcements. We announced that we now we have a prototype of the largest flash device ever made. It's a 3.5-inch device with 60 terabytes of storage in it. So pretty amazing. Following that, we also announced the fastest device in the marketplace today. This is an NVMe add-in card. We call it Joplin, or the 7200. It's 10 gigabytes per second and over 1 million IOPS. So it's a 16 by 16 PCIe card that is a full height, half length card, and can be added into really any PCIe 3.0 server. And then we also announced, the third announcement was the highest density in a device. That's a 2 terabyte M.2 gum stick. So what we're doing is we're going to take that technology, and for me, what I'm seeing is a movement from older 2U24, either SATA or SAS, all-flash environment, into smaller building blocks that include NVMe. And I'll talk a little bit about the reasoning, or the reasons I'm seeing this. But it's a pretty significant trend in the marketplace right now. It was also talked about in a lot of the keynotes. If you looked at the platforms that they were talking about for very high performance, high IOPS environments, what they were all showing were these 1U servers. But if you go into an IT center where things have actually been deployed even a year or 18 months back, you're still seeing a lot of these servers. So what I want to talk about here is really why that trend is happening, and then also how the total cost of ownership is going to apply to this. So as a conclusion slide, but basically what I'm going to talk about here is that we're seeing an order of magnitude, in some cases, performance increase between here and here. 18 months ago, and the servers that QCT and others are offering, this 1U NVMe 10 drive. And as far as our portfolio, what we've done is we've actually optimized our NVMe technology for this. So our NVMe drive, our U.2 drives that fit into this, are 7 millimeters versus 15 millimeters. So we get better airflow through the front end. They're also power optimized for IOPS, so that they still have a 12 watt envelope, which makes it more conducive for the designs, the heat, basically power and the heat inside of these boxes, because now we can actually focus more on higher wattage processors and actually the I/O on the back side. So what these platforms do is actually maximize your overall performance from front to back in the system, from ingest of data all the way to the storage and then back out without really any bottlenecks. In this case, we used to see a lot of bottlenecks. We'd have a single PCIe interface generally to an IOP that went to an expander out to maybe even a dongle type environment inside of these the carriers for the cards. And that's what gives us this difference in performance. So again, 51 BP, 10 NVMe drives versus either SATA or SAS 24 drives. What we see is 20% less power for this environment, much better MTBF because of the total number of components that are we've reduced in this environment, and then very, very significant performance increase. There, I'm getting to 5 minutes, so we're going to kind of move through this. This slide right here, big takeaway, the takeaways here is what we're seeing in that 1U environment, 24 gigabytes per second for sequential large block reads. That's in a 1U. I mean, we could get this out of a rack 5 years ago, and barely. So the jumps that we've made in 2 or 3 generations of technology are very significant. The other thing I want to take away here is that as we add each drive, we see increase in performance, so that in the older environments, what we would see is we'd have hotspots where a couple of drives would give us very good performance, but if we started spreading the IOs across all of the drives, we'd see other bottlenecks become prevalent in the design. It would be back on the single PCIe bus or on an expander technology. So this is where we talk about that ideal mix for this 1U server. 10 drives in the front. We don't really see any performance degradation because of the processors, the memory. The real limiting factor on this is actually the networking infrastructure going back into your IT center. And that's really being taken care of in a lot of areas right now. Same thing for sequential writes. And then for small block reads and writes, what we're really seeing, we're seeing very high performance again. 2.5 million IOPS for random reads, and then 1 million IOPS for 70-30 mix. So in a database environment, these 1U servers are giving the same thing that multiple servers it would have taken, even in the last generation, multiple servers to produce. So that was all synthetic environment. That was FIO, iometer, the kinds of things that the engineers are doing in the background to benchmark. But this is kind of where the rubber meets the road. This is actually a software-defined environment running Ceph. And this could be really, we've seen it across the multitude of environments today. The Microsoft person was talking out there about, she showed this exact same server in her environment as far as defining for hyperscale and hyperconverged. But what we see here is, on average, there is a degradation just because of the software overhead, but still over 8 gigabytes per second for sequential large block performance. And then same thing for the random reads. We see very high performance, much higher than anything we would have ever seen in one of those 2U servers. And then again, significant performance. The key one here is the 70-30 mix. Typical database environment for object, and we're seeing over 3 gigabytes per second performance, where in the older device, that was down in a 1.2 gigabyte per second. So back to this slide. Very, very significant improvement when we move to the NVMe environment or into these small 1U servers. The other real opportunity there is, because they're smaller, higher, or much better TCO, these devices give you the ability to scale out in a much easier method. So they're a smaller building block, allows you to have better granularity and lower cost as you expand and scale out. So I talked really briefly about this platform, NVMe, with our Panther drives in it, and how basically that's really an ideal high-performance all-flash building block. The other things I want to just kind of point out from a QCT point of view is, we've also seen a lot of interest in this JBOF. It's almost the second tier of the high performance or high accessibility environment. In this case, we can put 72 SAS drives in here. It has 8 12 gig SAS ports on the back. So into the infrastructure around this, we can get over 30 gigabytes per second. So it's similar performance into this, except in this environment, we've actually got a SAS SAN running into it. And as far as the storage itself, because of the 72 drives, we've got access to over 300 terabytes of raw flash, which is pretty impressive in a single platform. Again, years ago, that just wasn't available. And then a little bit of pie in the sky. The PH platform, this is a 1U 3.5-inch device that has 12 user replaceable drives. It also has compute in the back. Now in this case, if we add 10 terabyte drives in here. We also have the ability to add some SATA flash or M.2 flash. That's really an ideal platform for the converged environment. But if we start talking about putting the 60 terabyte drives, as you know, the environment that would probably go in is there probably aren't a lot of opportunities for that. But being able to do over 700 terabytes of raw storage, and then we actually announced the 100 terabyte version of that, or said we could build that as the NAND technology progresses. We're talking over 1.2 petabytes per U in a platform like that. It's pretty amazing. So that's really what I wanted to come across and let you guys know. From our standpoint, we're seeing the converged environment moving from these 2U building blocks down to the 1U, and the performance that we're seeing out of those is pretty amazing. So as those opportunities come up, if you want to talk to us, QCT and ourselves, we're available.